In today's class and video, we are going to look at how to determine the protein concentration of our acid phosphatase using the Folin-Lorry method. So first of all, what I want us to note is that before we will be able to determine the protein concentration of our enzyme, we will first have to plot a calibration curve using BSA, which is bovine serum albumin. So this is the calibration curve that we are going to use to determine the protein concentration of our enzyme. So as we can see over here, this is the equation of the the line giving us y equals 1.0036 s plus 0.00222. So where y happens to be the absorbance values obtained on the y-axis and 1.0036 happens to be the intercept or the slope. The s happens to be the concentrations on the s-axis, and the 0.0022 happens to be our intercept. And again, what I want us to note is that it is expected that the concentration of our enzyme, which is the acid phosphatase, should fall within the concentration of the BSA from the calibration curve. Therefore, it is important that we dilute our crude enzyme in 1 in 10 dilution, or 1 in 100 dilution, or 1 in 1000 dilution, and this allows us to get an absorbance values that will fall within that of the calibration curve, which will later help us to extrapolate and determine the protein concentration of the acid phosphatase. And this BSA calibration curve, we looked at it in our previous lesson, so I'll just encourage we go back and just revise it. So now let us start by looking at our test protocols and the materials needed for this experiment. So the first is a micropipette. We also have the pipette. We have the Folin-Chicato reagent being diluted in 1 in 3 dilution. We have our protein sample, and that happens to be our acid phosphatase. We also have a spectrophotometer set at 750 nanometer, our alkaline reagent, and our BSA calibration curve. So these are the various materials that are needed to perform this experiment. So now let us start by looking at the test method. So one, we are supposed to thaw the frozen acid phosphatase and perform a dilution of the crude acid phosphatase in either 1 in 10 or 1 in 100 or 1 in 1000 dilution. And what you also have to note is that if you want to perform this dilution, this is how it's done. So for the 1 in 10 dilution, we pick 1 ml of our crude enzyme and add it to 9 ml of distilled water. To perform the 1 in 100 dilution, we pick 1 ml of the 1 in 10 dilution and add it to 9 ml of distilled water. And to perform the 1 in 1000 dilution, we pick 1 ml of the 1 in 100 dilution and add it to 9 ml of distilled water. So this is basically how the dilution is going to be. So step 2, to 1 ml of each phosphatase solution, and that happens to be the crude, the diluted enzymes in 1 in 10, 1 in 100, and 1 in 1000. We add 5 ml of alkaline reagent and mix, and we leave at room temperature for 10 minutes. And this is where the first reaction occurs under the Folin-Lorry method, which happens to be the biuret reaction. So after that, we add 0.5 ml of the Folin-Chicato reagent to each of our sample. So we also have the crude, so we will add 0.5 ml to the crude, to the 1 in 10 diluted sample, to the one in 100 and the one in 1000 diluted sample, and we incubate at room temperature for 30 minutes. So after incubation at room temperature for 30 minutes, we read the absorbance at 750 nanometer. So let us look at our assumed table of result. So as we can see, so this happens to be our enzyme, which is the acid phosphatase, and these are the measured absorbance values for each. So if you should look at the crude, we have an absorbance value of 1.835, and for the 1 in 10 dilution, we have an absorbance value of 0.767. For the 1 in 100 dilution, we have an absorbance value of 0.241, and that of the 1 in 1000 dilution, we have an absorbance value of 0.022. So what we are going to do is that we are going to use this calibration curve to extrapolate and determine the protein concentration in each of the enzyme samples over here. So if we should look at this, we have the equation of the line to be given as y equals 1.0036 s plus 0.0022 with our r square value to be 0.997. Now, so what we have to do is that we have to make s the subject from this equation, and we also have to notice that the s that will be obtained, the value for the s that will be obtained on the s-axis from our calibration curve will be the extrapolated or the determined concentration of protein in our enzyme. Now, so looking at the table over here, now we can also see that the absorbance value for the crude is 1.835, and it's like it falls outside the absorbance values for the calibration curve. And that of the 1 in 10 dilution is also 0.767, and that also falls outside the absorbance values here. And that of the 1 in 100 dilution is 0.241, and that also falls outside the absorbance values on the calibration curve. And that of the 1 in 1000 dilution, which happens to be 0.022, falls within the absorbance values on the calibration curve. Hence, I would say it is best to use the 1 in 1000 dilution value to extrapolate and determine the concentration of our enzyme. So what you have to note is that from the table, as said earlier, the 1 in 1000 dilution should be used since the absorbance falls within that of the calibration curve. And using the equation of the line for the calibration curve, which is given as this, and making S the subject from this equation, the protein concentration of the acid phosphatase will be 0.022 milligrams per mil. But what we also have to note is that we made a dilution of our crude enzyme, so the actual protein concentration for the crude enzyme will be this value obtained multiplied by the dilution factor, which is 1000. So you'll get 0.022 milligrams per mil times 1000, and this will be equal to 22.0 milligrams per mil. So the actual protein concentration of our acid phosphatase is 22.0 milligrams per mil. Thank you.